to you, Nikita.
Thanks, Logan, and thanks, Alexa. So, everybody, nice to meet you all. Good morning, good afternoon. I know people are joining from different parts of the world, hopefully. So, let me share my screen. And so, this is where we'll begin, right? So, Lab 1 specifically, we'll be going through how GitLab enables us to shift security left and catch our security mistakes right at the merge request, right? Instead of waiting months later during any audit event or any security scan randomly that takes place. And we'll also go through the code review that enables security scans and create a merge request to bring it into main. This has been the buzzword for like forever. Like, what is this shifting left? So let me share with a simple analogy that perfectly captures why we need a shift left in our security approach. So imagine looking at this picture, you have spent like hours of building this beautiful sandcastle on the beach. You are proud of your work and it looks amazing, right? You're ready to show it off. But wait, you suddenly notice the waves are getting closer, and all that hard work, all that time, and all the efforts that you invested are just going to be washed away. If only you had checked the tide schedule beforehand or built some protective walls around your castle earlier in the process, you could have saved yourself from this disaster. This is exactly what happens in the software development as we all know it. By shifting left, our goal is to find and address any potential security vulnerability earlier in the development cycle, rather than doing it after the fact. Because there is a reason to it. Why do we want to shift left? Just like building castles in a safer location or adding more protective barriers could have saved this sandcastle, similarly, the cost of remediating any vulnerability, if found out later as a matter of fact, could be a lot. And how does GitLab does it? Like, now that we understand the importance of shifting left, let's talk about how GitLab makes it possible. GitLab is the leading DevSecOps platform that empowers your team to balance speed, security, making sure your software delivery is automated and secured from end-to-end software supply chain. What you see here is the complete DevSecOps lifecycle. And notice how the security isn't just bolted on the end, it's woven throughout every stage of your software development, all the way from planning, creation, verification till deployment, monitor, and governance. So you could manage threat vectors proactively across your SDLC, secure the software supply chain from the very first commit to production deployment, adhere to any compliance requirements without actually slowing your development velocity, making sure that you have gained visibility and implemented system-wide governance that scales your organization. So honestly, isn't just about having security tools. It's also about having security intelligence built into the fabric of how you build and deploy your software. Just the minutes before, like I said, there are literally some statistics that drive us home on why shifting left isn't just a nice to have, but it's critical for your business. So we are looking at 59.5 billion annually in software bug cost, with average data breach around like 5 million and with a 72% increase in breaches since 2021. And these problems are not going to stop or get lesser with the oncoming of AI and the various tools we're using for that. You know what is the eye opener on this slide? Look at how the cost of fixing a vulnerability explodes as you move from coding stage to the production stage. From 2.4 hours to literally 13 hours nightmare in production, which is like 5 times more time in remediation efforts. And honestly, this isn't just about your developer time, it's also about your customer trust, some regulatory compliance, and obviously the business continuity. Now look at the bright side. Now see how GitLab security flips this equation and provides a positive impact. This data is coming from a Forrester Total Economic Impact study for a large organization where we had like 3,000 initial users growing at a rate of 25%, and an annual revenue of $60 billion. The results speak for itself. If we try to sum all of this number, it's almost around like 100 million in the total economic benefit from GitLab's integrated security approach. Make sure that I'm emphasizing on the fact integrated security, not the point solution, but embedded and native solution within GitLab itself. So we see a massive saving across multiple dimensions. People ended up saving 4.8 millions in avoiding lost revenue from security incidents, to 44 million saved through a reduction in time spent building homegrown security tool. And then overall, 48.3 million saved through greater efficiency in managing vulnerability. And that's the power of having everything in one platform instead of doing the context switching, having multiple point solution. Let me prove my point with this picture. Notice how the security isn't like a separate step that slows things down. It is seamlessly woven into the development workflow. You see these green check marks. These represent the security scan that have completed successfully, such as your container scanning, dependency scanning, secret detection, license scanning, etc. All happening automatically without any developer intervention. At the same time, the positive side is the developers get immediate feedback on both functionality and security. So they can fix the issue while the code is still fresh in their minds, right? So no going back and forth. Or like I said, doing some scans after the fact. So this is what the developer efficiency looks like in practice, where security that works at the speed of development and not against it. Another thing that GitLab enables us to do is an end-to-end governance. So you're looking at this GitLab's security dashboard, and again, we'll see that during our demo as well. So this is where your security team gets the visibility they need without slowing down your development teams. What you see here is the project security status graded by highest severity vulnerability present. So if where it says F, like all the way from A to F, is the severity levels of the vulnerability found out and in which project. So it'll give you a quick identification of the projects that need immediate attention and help them to prioritize the efforts effectively. So over the period of time, you would see, hey, what's the trend of these vulnerabilities look like for 30, 60, 90 days? Have there been an increase, a drop? And we'll, again, like I said, we'll see that in the demo as well. Finally, this is the dashboard. I like to call it the executive view. So this is GitLab's value stream analytics, where your leadership gets complete visibility into how efficiently your entire SDLC is performing. So you could see some critical performance metrics with, hey, what's the lead time? What are the cycle time, new issues, new deployments? One more important thing is this DORA metrics. How has the deployment frequency changed per day within my organization, right? Or within a specific group or a project? How the lead time has changed? Has there been any change in the failure rate? All of these are important and critical DevOps performance indicators. And with this level of insight, your executives can make informed decisions about resource allocation, some process improvements, and of course, demonstrate the business impact of your DevSecOps platform. All that said, all of this is the power of GitLab's integrated platform. You have fast development, secure governance, and efficient delivery. Last but not the least, GitLab does provide the holistic approach to security. And that is something that sets GitLab apart. You're securing every component of your modern application stack. So in today's world of applications where we have most of the apps in containerized, your application security extends far beyond the code you write, right? So GitLab offers secure container registries to protect the built images and the packages that are just as critical to your security posture. What you see here is a protected container registry. And this is just a sample, like I said. You can set the repository path patterns with wildcards so that all these security policies automatically gets applied across multiple related containers. One more thing I would say to notice at is the minimum access level for push. And this is which is currently set to maintainer. What this does, it ensures that only the trusted team members can update your container images. And this addresses one of the biggest security challenges in the container management today. So this feature will give you complete control over push and pull interactions with your images. So you don't have to worry about, who can deploy containers, but also who can access and modify them throughout their life cycles. All right, so now the fun part begins, and we'll be going through our first lab exercise, which is shifting left. Hopefully, all of you are into this already, and this is where I'll submit my code. Like Logan mentioned, you would see your name and your GitLab user ID at the top of this page. So I'll just submit the code. Open the GitLab workspace and just give it a few seconds. Even this might have happened for you, like just takes a couple of seconds for our lab to show up here. I should have done this beforehand, but I wanted to make sure that you are able to see the pages, but yeah, giving it a few seconds more. Oh, there you go. My demo gods are with me today. So one thing that I would like to say here, this is what I recommend. There are I would like to keep two tabs open. So I could go through the instructions as well as I could execute or implement those instructions as well. So I'm going to open two tabs and you will see that our base security workshop has loaded completely. We have the application. This is our repository with all the files. You don't have to do any changes here. This is where within the issues where you need to be. By now, for all of you, this might have loaded and you would see shifting left as the first lab exercise. So let's get started with this one. I hope everybody's on the same page as I am. All right. So this is like if when you click at the shifting left, you would see a preview of it. And what I generally like to do is just expand it so that you can read those instructions completely. Like I said again, we'll have two tabs, one where I'm actually going to implement those instructions and the other one where I'm going to read those instructions. So now I have like multiple screens. If you have, that's perfect. But what you could do is you could also focus on what I am trying to do and follow the steps along with me. Or like Logan said, these labs will be available to you for next 5 days. So you can do it self-paced as well. Feel free to drop any questions and let us know in the Q&A. All right, so getting started first. If you have used GitLab before, this page should look familiar a bit. Otherwise, this is just one of the GitLab issues that I've opened. And going by the instruction prep. So as you get started, I might skim over these details because I've done it like a couple of times, but feel free to take your time and read these instructions at your own pace. The first thing that we would like to start with is assigning this issue to yourself. So you would see that in the top right corner in the assignee section. So this is where you would see it. So what I'm going to do is, in the shifting left, this is where my execution tab is here. So I'll assign this to myself. Then we want to make sure, like first things first, here is the scenario. We have this Tanuki racing application. Not always my developers would include the scanners in their code. Or another thing, what if they just skip to get past that stage of scanning that's getting done? So this is our first exercise where we are going to enforce, like my security team is going to enforce the scanners to be implemented across specific projects, entire group, or a specific, again, like project to be implemented. So I'm going to enforce those scanners to my developer projects. So what we need to do next is use the left hand navigation menu to go through the build and pipeline editor. Here you would see the current setup. The pipeline, so let's do that. When I go to the pipeline editor, this is where I would see my YAML file. Look at the document, like so far we have a few variables defined. We have the stages defined as build, test, release, using a specific image here in the build phase. Nothing really talks about including any scanners. And this could be a common practice. Our developers might include, like I said, or maybe not. So what I'll do for now is, this is looking good. As next steps, we'll click through build and then pipelines, click on the button with new pipeline, keep the branch selection on main, and run that pipeline. So all we have to do is just with this existing GitLab YAML file, I'm going to create a new pipeline and just run it as is. No changes done, nothing to be touched there. And in the interest of time, like you would see a lot of things in the UI. Feel free to ask any question. Hey, what does this specific tab does? Or what is this specific input variable? So feel free to put those questions in the chat. But in the interest of time, I'm going through as our lab is there. So just running a new pipeline. Now, what you see here is, of course, the build stage, test, and release stage. You could see the associated jobs here as well. And this would take a couple of seconds. What we want to do next is, like I said, in this atypical scenario where my developer didn't include any scanners, I'm changing the hat, and now I am the security team member who want to enforce these scanners. For that, what we'll do is, using this breadcrumb that you see at the top, we are going to create a new project and a blank project. There's a specific name that we would like to give it as, which is Tanuki Racing Scanner Pipeline. So what I'm going to do is, at the group level, and this, you might see that my group number or the ID is a little bit different, and this is going to be unique for each one of you. What I'm going to do here, at the group level, I'm going to create a new project, a blank project. Again, as per the instruction, just copy the project name as it mentions it to be, like Tanuki Racing Scanner Pipeline. You just want to leave all your settings as is, no changes done here, and create the project. Okay. Okay. So this is where I made the change here. So next up, we created a separate project, right? All you have to do is next, in that newly created project, not our existing base workshop, not that one, the newly created empty blank project, which is named Tanuki Racing Scanner Pipeline, just copy this configuration for GitLab YAML file and paste it in the pipeline editor. So again, as a reminder, not in the base security workshop, but in the Tanuki Racing Scanner Pipeline, within the pipeline editor where we define or configure our YAML file, just remove everything that you see here and paste the copied code from here, right? Let's look at how we are trying to enforce and what configurations we have in this YAML. Right now, I have not specified, hey, this is the project that you need to enforce this specific pipeline. All I have done is I've included certain templates for container scanning, for code quality, dependency scanning, secret detection, and SAST IC. As you see them here, these are like reusable templates and are provided within GitLab itself. These are created by us, managed by us, and you could straight away use them. You can even modify and define or create own reusable templates, which are customized to your organization needs, and just commit the changes. That's it. Just, okay, so I have the pipeline ID here. It's just going to show me, hey, these are the included templates where we would do code quality, container scanning, Kix IAC, secret detection. Let this work. And going back to my instructions. So this is what we did. We looked through the include section where we have seen like different security templates. One more thing that I would define here, look at, uh, one second. So where is in the pipeline? Just one more thing that I wanted to highlight in the pipeline editor, even though like you have defined, like I said, these templates, within the full configuration, you could see what each one of these template is doing. So here is where you have the entire configuration to review what your templates for these scanners include. Okay, so going by the book, this looks good. We have committed the changes. Now is the interesting part where we are going to enforce this newly built pipeline onto the base security project or the workshop. So how do we do that? Let's go back to our group level. This is the Tanuki racing pipeline we just built where we have included the templates for scanners. This was our base security workshop. Within the base security workshop, remember we left at running the new pipeline as is, no changes done. And it still looks like this, right? Just build lint testing, some testing, and then semantic versioning release. Now I want to, as a security manager or a security team member, I want to enforce my created pipeline scanner or policy scanner onto this base security workshop. So what I'm going to do is under secure, on the left-hand navigation, you would see under secure policies. Okay. Currently, there are no policies. Remember, there is a right now, I'm defining these policies for this specific project. But at the same time, you can define policies at the group level as well. So creating a new policy, you would see multiple options. We have merge request approval policy, we have the scan execution policy, pipeline execution policy, vulnerability management policy. We will go through each one of those during our workshop today, so need not to worry. But to begin with, like you said, we are starting with pipeline execution policies where I am enforcing certain customized pipeline onto another projects or specific project pipelines. So let's start with pipeline execution policy. Um, what I'm going to do is just give it a name, enforce security pipeline policy, just as is, and add some description. Um, we have enabled this status for this policy. This policy, like I said, applies to your current project. But if I had to do it at the group level, we can do that as well. But for demo, like for workshop purposes, let's just do with the uh, project. So injecting into GitLab YAML with the following pipeline execution file. Now this is where I want you all to be careful. You would see scanner pipeline, like lot of scanner pipelines here, right? My group ID is CA1ER3W. When you hover over the scanner pipelines, try to look for your group name. So for me, how about I just, let's try this. Okay, there you go. So I just copied the like my group ID and I'm going to use the Tanuki Racing Scanner pipeline. Again, as a reminder, this is the project where we have defined the templates that needs to be included. So make sure you select your own Tanuki Racing Scanner pipeline, and I tried to filter it with my group ID, which is at the top level breadcrumb. So selecting that, copying the GitLab YAML file here. So this is, remember, our templates were defined in the YAML file, leaving all the configurations as is. I just want to be sure, like yeah, so select the project. You have created the pipeline execution policy. You have leave the injected section as is, select the project, choose our scanner project, which is Tanuki Racing Scanner Pipeline, and then just create the new policy on the resulting page, click merge. That's it. So looks good, no changes to be done here. And create the new project. With the new policy. One thing that I also want to highlight here, when you are defining this policy, see how, okay, give me 1 minute. There's one thing that I wanted to showcase, which is when you define these options within the policy, you could see the YAML mode of it as well. So, 1 second. Let me just create a new one and I'll show you where. So within the YAML mode, like right now it's empty for me, but if you haven't progressed through this step, you would see the pipeline execution in the YAML policy defined in the YAML mode as well as on this side preview window in itself, right? So going back, this looks good. I have created the policy. I'll just merge it. Now, one thing to note again. Remember when we started the project, we had just the base security workshop. As soon as I created my policy, look at where it created my policy into. It created like a separate project. So let me show how it would look like in the group. Within the group, you would see this additional project created, and this is the value of GitLab, where we want to centralize one place where my security team can view all the policies in a separate project. So I could even, like, as a matter of fact, for separation of duties, I could hide this project from my developers and just so that it's more accessible to me and I can make the changes as a security developer, security manager. So this gets created automatically as soon as you define the security policies under secure and then policies. So for each project right now, I have defined like for base security workshop, I created a policy and that resulted into creation of this security policy project. So you should see these three for now. Okay. All right, so let's go ahead and create a new branch to track our future changes. Use the left-hand navigation menu to click through code branches and then click new branches. Create create a new branch called secure pipeline. Make sure it is based off of main. So just as a next step, we want to do with from the base security workshop, create a new branch. Okay. And you would find the branches tab under code. Give it a name as secure pipeline and it is based off of your main branch. All right, this looks good. Now, so I didn't touch on one thing during my presentation, but you might have heard through all the marketing we have done for our GitLab Duo. GitLab now is embedded with GitLab Duo, which is our AI suite. And our goal and our focus was to embed AI not just for assisting the developers, but making sure it's embedded in each part of the software development lifecycle. So all the way from your planning phase till the impact dashboard of where I could have an oversight of, hey, how AI has made an impact in my organization in the projects. This is where GitLab Duo got introduced. And now this is what we are going to do. Uh, we could ask GitLab Duo provided a few natural language prompts and see what it does. And where is GitLab Duo in the UI? You would see that at the top right corner. See how it has some pre-populated questions. So if you have anything, you could ask for help or select one of these questions as the common, frequently asked questions. What if Let's just ask what security features does GitLab have? Just a common question. You could even ask it to make a pizza and give you the recipe in French. You could ask any such question as well, but let's see how it provides you a response. So it's a comprehensive response where it would say, hey, based off of the GitLab documentation, we have several security features such as 2FA, some SAML sign-ons, fully isolated environments, and so on and so forth. How many security scanners does GitLab offer? So throughout, of course, we have a wonderful team helping with me today, and please feel free to ask question on the chat as well, on the Q&A as well. But if you have any question, you can definitely use GitLab Duo chat. Look how it maintains. I've been talking to Duo for quite some time, so now you would see like the chat history in the GitLab Duo as well. So this is how GitLab Duo has been helping us. So next step, coming back to our step number 4, and which will conclude the issue number 1. Let's create a merge request. So what we have done so far. We have defined a security policy, which is a Tanuki racing scanner pipeline that has templates for our security scanners. And we have enforced that policy to our base security workshop. Now I want to test that. I want to make changes in my project, which is coming back as a developer. I want to come back to this project and make changes to it and see if the pipeline execution policy would enforce certain scanners into my pipeline. So within the new merge request, going back, let's create a new merge request here. And we want to select secure pipeline and the target branch, keeping it as is to main. So let's continue by creating this new merge request. I think we should uncheck the mark as draft. You could assign this merge request to yourself and make sure you uncheck delete the source branch when merge request is accepted. So couple of things to keep a check. Make sure that you uncheck mark as draft. Assign it to yourself, that's optional. Uh, Definitely uncheck delete source branch when merge request is accepted. So I'll did that and I'll create a merge request. That's pretty much it. Then I want to, as you might or might not know, GitLab does comes with an embedded web IDE. So at the top right from code, I want to select open in web IDE to make some quick changes to my code. The place that you would want to be is within the lib folder, Tanuki Racing app.rb. On the line number 42, just change the title and make it this. So I'll just copy it from here. So under lib Tanuki Racing folder, app.rb. So at line number 45, so this is where we are. Currently it says Tanuki Racing Home, but we'll replace that to Secure Tanuki Racing because now that's what we want, right? So title change to Secure Tanuki Racing Home. Just making that, just want to be sure that we create the merge request and push it to the secure pipeline. Okay, again, as a not so good developer, I should have added the commit message, but I missed that. Please do the good thing, add the commit message while you're trying to commit the code. And go to the merge request as it notifies within the web IDE at below at the bottom of the right hand side. So we have this merge request created, right? We have changed the code. We are in the base security workshop. Let's look at the pipeline. Ta-da! We see, even though in my project, if you go back to my pipeline editor for this base security workshop, still I don't have any scanners used here. But then due to the policy defined, which is like my pipeline execution policy, I am now enforced to run these additional tests as part of it. And there are a lot of questions that often get asked, like, hey, we have implemented rollout strategies for implementing these scanners for various projects. So there is definitely in our public documentation as well. But if you're working with any GitLab solution architect account team, feel free to talk to them about how do you roll out these policies? Because often it could get overwhelming for the developers when they start seeing like so many things and they start getting blocked. So have a discussion with your account teams for GitLab, and they'll help you on more details with that. All right, so this will take a few seconds or maybe a few minutes to run it, but I just want to be sure like we completed all the steps, and that's it. That's it for uh, the first issue. Logan, I want to do a quick check because this is going to take a few minutes to complete. How about we take like a 5 minutes break? If you're running on time, if you're running late, I can continue with the next lab.
No, yeah, we can definitely take a 5 minute break.
Okay, perfect. So, all right, so I'll see you back within 5 minutes, and hopefully all these tests has been completed, all the scanners have been completed by then. All right, back in 5 minutes. All right, team. I hope you are at the stage where you would see some warning signs, which is fine, which is completely fine, because that gives me a segue to tell you about something interesting again, which is um, you see this code quality has some warning signs. So if I click into this code quality, generally you would see logs, which is like so much. I'll have to go back and forth across the lines, find out what's happening, figure out how to fix it, all of those details. But with GitLab Duo is what we have this troubleshoot. You see, that's like a prized possession, right? Because figuring out why the pipeline has been failing, how to fix it has been a challenge for a lot of us in that SDLC workflow. So as soon as I click troubleshoot, you see how it triggers a command, opens GitLab Duo chat, and help us figure out what's the root cause of this pipeline. Why is it breaking? So that's just a quick thing I wanted to highlight in your free time, but do not do it now. I'll just walk through because I like to talk about Duo as well. You could see that. So root cause for failure, you would see, hey, why is it failing? What's the root cause of it? What is an example fix? And it will also provide you a code snippet for that. So this is where GitLab Duo has been really helpful. It will give you some recommendations, some best practices, some example fix as well. So try that out if you're interested, and hopefully it helps you all. So going back, this looks good, but for the developer, for these security engineer, that's one of the blockers, right? This gives us a good point in time to move to our issue number two or lab number two, parsing the results. Let me expand that. We're going to use, again, let's scan and parse through the result of what it means. Like I said, our goal within GitLab is to bring all your findings close to the developer so that he could quickly act on it while he is working on the code. The code is fresh in his mind. He's aware what changes he made. So what I want to do is, as a developer, if you go back to the merge request, we created this secure pipeline merge request here. And you would see, thinking from the lens of a developer, within my merge request, once the pipeline is parsed, I could see there have been a few license compliance issues detected. Uh, it is loading. It's going to come up. All right. So you could see, again, from the lens of a developer, I could see, hey, 5 license compliance issues detected, 49 critical issues detected, 4 high, and 13 others. I'm a good developer. But then there are a lot of vulnerabilities which are not just associated with my code practices, but the dependency I might be using, the containers I might be using. So if we could see like there are some 24 critical SAST vulnerabilities, dependency scanning, container scanning. And if I open any one of this, let's say critical RDS storage not implemented, it would give me what's the severity level, which project is it coming from, what tool did I use, and what scanner found this vulnerability. Also, the location that it was found out. Now, here's the thing. Two possibilities. I might create an issue so that I could start working on it, create an issue for this specific vulnerability, start fixing this vulnerability, fixing the code for it. Or there is a possibility that I'm aware my security team has been working on. There is a known vulnerability which my security team has been working on resolving. So I could simply dismiss this vulnerability. But there's a catch. If I try to dismiss this vulnerability, they would ask me, hey, give us a required dismissal reason, and only then you can dismiss this vulnerability. So, this is how we could look at, and again, the fact that bringing those findings closer to my developer so that we can work upon the cost of remediation as further left as we could. Now I'm starting the lab two. So we looked at the section where we could see code quality, license compliance. There was a full report generated for that. Another thing in my presentation is where I talked about security dashboard, right? So if you go under secure and security dashboard, okay, one second. And this is happening because Logan corrected me that I should merge the request. So let me just merge this secure pipeline. And again, like I said, this is going to, yeah, so did I have the merge request drafted? No, nothing else. So we would wait for this to populate my vulnerability report as well as my security dashboard. So under the secure section, you would see two reports. One is the security dashboard, one is the vulnerability report. This would give us like a few, it would take like a few seconds to minutes to populate these two dashboard where I could see an aggregated view of, hey, these are the security findings, these are the vulnerabilities found, this is what the location is, and I could start working on that. We'll come back to it just in a minute. But going back to my presentation. So we have started lab 2. We have parsed the result in the merge request widget. And we are going to talk about this lab 2. Now that we have our merge request pipeline, it has been completed. We know we would want to get it merged. Let's look at the results into the scan, uh, as well as create the policies we may need to prevent for certain security. So we are proud of this section where we provide the security and compliance scanners as well as some overarching capability. On the pre-built side, you would see certain scanners which are already part of GitLab, such as secret detection to catch any exposed credentials, SAST for static code analysis, infrastructure as code scanning for scanning your Terraform, CloudFormation, Kubernetes manifest for any security misconfiguration. Also, we have the post-build scanning where GitLab really shines with DAST or dynamic testing capabilities. So we have the DAST dynamic application security testing. So this would be where which test you're running applications for runtime vulnerabilities that sometimes the SAST might not catch up. Two things that also are included are the first testing, which inputs certain unexpected and malformed data into your application to find out any unknown vulnerabilities, any edge cases. So more like penetration testing as well. Comprehensive AI security testing that analyzes your APIs for both known and unknown runtime vulnerability. Now, the foundation of GitLab's security approach lies in these overarching capabilities. There are many tools in the market. They will give you these scanners. They will provide, like, I think it's a combination of few scanners that's provided by one tool, then another tool provides another combination or a set of scanners as part of it. Then you use another point solution for building dashboards, aggregating the results. That's a lot. With GitLab, we have the vulnerability management, which I'm going to shortly share it with you in the UI. And that vulnerability management gives you full visibility to view, triage, track, resolve your vulnerabilities across the entire organization. Then you have the dependency management to track or your SBOMs, right? So dependency management to track the dependencies used within your project. Security and license approval for any approval that's required from the security team when a merge request has newly detected vulnerability or licenses. This is what we're going to do in the lab. And scan enforcement, we just did, right? We did some customization, created a Tanuki scanner pipeline, and had some templates within that so that those scanners can be enforced to be applied in the application project that I'm working on. Like I said, you saw, let me go back quickly into the vulnerability report. It's not yet there. Okay. But this is what the numbers would look like, right? As I said, adopting security scan can often be daunting when they first run, especially if it isn't a fresh project. You can see from these numbers even our workshop project already has. This is intentional. We do build great code, but this is intentional to showcase how we could catch these number of vulnerabilities within the workshop project itself. So looking at this number, it makes me think, hey, where should I even start? And this is where many security initiatives stall sometime. Teams get overwhelmed by the sheer volume and not sure where to effectively prioritize these vulnerability. So this is exactly where GitLab has integrated the exploit prediction scoring system, EPSS, into our GraphQL APIs. Now, these scores will help you make your data-driven decision by predicting which vulnerabilities are most likely to be exploited in the next 30 days. So instead of looking at severity levels, what this ESPP score does, it gives you an intelligence about real world threat likelihood. Like, let's say a medium severity level vulnerability with a high EPSS score might be more urgent than a high severity issue. So that might be more important to resolve a medium severity level vulnerability having high EPSS score than the urgency to resolve a high severity issue, right? So additionally, with our newest vulnerability management policy, you could systematically manage these policy as you work toward building more secure application. You can set certain rule based on EPSS scores, not just traditional severity ratings. So you could do that as well. One thing that I want to highlight about the GitLab policies are like two fundamental policy types that works together to create this comprehensive security governance. So scan result policies, these take actions based on the scan result. So let's say you require approvals when the vulnerabilities are detected, and I require more than two people to approve my merge request, so that if there is a vulnerability and there is no one point of contact for approval of these vulnerability, and I'm able to proceed forward because one of the approvers is out of office, but the other can approve my merge request. So that's how the scan result uh, policies can work. Then the scan execution policies. This is where you would want to ensure that these security scans actually run either on a specific schedule or as part of your project pipeline. So what you see here is a policy creation interface. We just saw that, right? Where you can define the rules, set severity thresholds, specify which scanners to use, configure actions like requiring approvals, etc. This is actually policy as code in action, and it requires your security requirements are defined, version controlled, and automatically enforced. Now, like I said, remember how I showed you another security a policy project gets created anytime you create a policy. So this is the key architectural advantage where one security policy project can govern multiple development projects. So here in this example, we have security project A that controls both development project A and development project B, versus there is a security policy project B that just controls project C. So this is the one I showcased how it automatically got created and was controlling, for now, just one of my base security workshop project, right? Now, if you see here, this is where what the developers could see. We have GitLab security bot, which automatically notifies the teams when policy violations are detected with clear guidance and what needs to be addressed. So notice here how it says approvals approvals are required due to one or more policy violation. So this keeps the development moving while ensuring security requirements are met. Talking about the GitLab compliance. So GitLab compliance enables you to define rules and policy that adhere to compliance framework and common controls. This isn't just about security, right? It is about meeting the regulatory requirements like SOX, GDPR, HIPAA, and other industry specific standards. Starting with the foundational elements here, such as granular user roles and permissions. This lets you define precisely who can do what in your organization. Similarly, for separation of duties, requires multiple actors to complete critical tasks, making sure increasing protection for both error and malicious activities, right? So, like I said, no single point of contact, but then we could define a group of users who could basically review my merge request with the vulnerability, approve or deny it. Then again, as most of the applications, access control provides two-factor authentication and expiration tokens to secure your environment. The compliance setting, this would allow you to define and enforce compliance policies for specific project, groups, user, as per your governance to match your organizational structure. From the operational side, credential inventory, and that helps you keep track of all your credentials that can be used to access GitLab self-managed. Of course, the protected branch for controlling unauthorized modification to critical branches, and merge request approval rules on defining how many approvals a merge request must have before it can be merged and who can provide those approvals. We'll do that shortly now. One final thing before we head towards our second lab is compliance framework. So GitLab has this comprehensive compliance framework that ensures compliance directly from your CI/CD pipelines. The key advantage is that these frameworks are set at the top level group's compliance center, right? So this means when you configure a compliance framework once, it automatically ensures that all pipelines across your organizations will run the necessary jobs in the correct order. No more manual configuration per project, no more compliance gaps. You could actually apply up to 20 compliance frameworks, and this is crucial for an organization that has that has to meet certain regulatory requirements, such as financial services company would comply with SOX, PCI, DSS, GDPR all at once. So you could have like 20 different compliance frameworks per project. Framework not just do that, but supports hundreds of different compliance requirements, all the way from approval rules that enforce separation of duties to infrastructure as code scanning that ensures your Terraform configurations meet the security standards. If you see here in this picture, project section at the bottom, this shows which projects will be covered by frameworks requirement and policy, and it will give you a complete visibility into your compliance coverage across the entire organization. All right. With the blessings of demigods, let's move into the second lab, which is parsing the results. We did start it already, and let me refresh. And there you go. So we have, it just takes a few minutes, like I said, to run the pipeline completely. We have critical, high, medium vulnerabilities, all of those with when they were detected, what's the current status of it, what's the severity level, the description, what identifier, and the report type. Let me choose this one. Okay. When I select any of the vulnerabilities, I could see, hey, see, from looking from the lens of a developer, I am not a cybersecurity expert. I need to understand what a specific vulnerability means, how I could get impacted, how my code could get impacted through that. Where was it found out? So, which scanner found it out? What solution could be provided? So, this is one of the examples. Let's show you something with the scanner. Uh, let's refresh it again because I want to highlight one thing. Going back to my issue number second, making sure that I run all the steps that's required. So we have gone through the merge request. We saw how like the results from our security scanning are presented to our developer. Breakdown of each and every SAST, how many SAST vulnerabilities were detected, how many container scanning vulnerabilities were detected, and all of that. We could also see, we also did a little bit on how to dismiss a vulnerability or creating an issue to resolve it. The next step is we want to scroll down, merge our code, which we did that and completed the pipelines. So next up, we should look through the security dashboard. This will bring up a dashboard view for all the security vulnerabilities. They count over time so you can track your work. Let me go to again secure. One second, not here. So security dashboard. This was the piece I was talking about. So you could see how we have the vulnerabilities detected here. So refreshing my page here. And over the period of time, hey Logan, just a quick question. We are unable to see the breakdown as per the project severity status, right? The grading system we have. Did I miss any step here?
No, it's because it's just today that this dashboard takes time. Believe that in the instructions we also link out to later, like more complete security dashboard that will have better results.
Yeah. Okay, so let's give it a few minutes. And going back to my, see, it is still discovering, it is still working in the backend to find out all the critical vulnerabilities reported within the dashboard. Today, we have a little bit of slowness in the instance. So that's where some of the things that you see here are not showing up properly. What I want to do is select the report type, SAST scanning. So here you see, I have a few SAST vulnerabilities which were detected. Now, often, as I mentioned, I might or might not understand what this specific vulnerability is doing. So let's select any of this. Like EC2 instance has no IAM role. Even though this is like very much intuitive enough to talk about, hey, this is what it means, and this is the line where it found out. Let's ask GitLab to help us explain this specific vulnerability. What does this mean? Like I said, as a developer, I might not be a security expert to understand each and every vulnerability. Hence, I can use GitLab Duo Chat to help me understand what is this vulnerability about? What's an example fix for this code? What this vulnerable code in the example looks like? Even that, the attack scenario, how an attacker, if it gains access to your code, how they might potentially exploit this vulnerability. So if you want to do like a reverse engineering and reverse testing, right, you could use the sample code to find out, okay, how am I am able to breach a specific vulnerability and exploit that. And at the same time, a fix to adding an IAM role to the EC2 instance. So any fix to basically resolve this vulnerability as well. There are also a few best practices as recommended by GitLab Duo. So this gives you a comprehensive expansion of, hey, this is what your vulnerability means. This is what a possible attack scenario might look like. And this is how you should resolve it, right? So another key feature, I'm just finding out another good example where I can share. It's one thing that I wanted to highlight, but maybe we don't have a good example here. But what you could do is, if you see, we have two options here. Explain with AI, we just did. Resolve with AI is currently disabled, but I say like, hey, GitLab Duo, if you could explain me with the vulnerable code, what it means, how it could be attacked, why not just resolve it for me? Right now it's disabled because we have a list of certain CWEs currently supported for helping us automatically resolve the vulnerability. And this is that list. So I was trying to find out an example where I can help resolve with AI a specific vulnerability, but it needs to fall under this section, like block of selected CWEs for vulnerability resolution. All right, so next up, one thing, let's go back and look at, explore like what other vulnerabilities are here. So if I go at scanner, no, I don't want scanner because it just doesn't show me things that I want. Refreshing the page, report type, secret detection. So good news is that we have not yet exposed by mistake, unintentionally, any of the secrets within the code. We have not yet done that. And we want to make this as a practice, right? I would want to make sure, like, even going forward from the security standpoint, that no vulnerable code or no sensitive data gets leaked into the code. This is where our next step number 3 is creating a policy to do a secret detection and define certain approvers in the merge request for approval policy as well. So now we looked at the vulnerability report. There have been no secret detection, and this means no secret data or secure token has been leaked so far. And definitely we would want to keep it that way. And to prevent this from ever happening in the future, we can set up a new policy to run all the future merge requests. For our use case, we will use leaked tokens for a use case, leak tokens are easy mistakes that can lead to massive problems. So we will create a policy, quick policy to stop that. So what we could do is create a new policy to find out basically, so merge request approval policy is the first one that we are going to do next. We define the enforce security pipeline policies. This is what you should see under your secure policies tab. Next up, I want to define a merge request approver, or like I said, a set of approvers who could basically check that any security vulnerability was detected and it's that their approval is required for a specific merge request to be merged, right? So let's create that. Merge request approval policy. This is optional. I could just copy paste this. Now here is the rule. Look how as soon as I start making changes to the GUI, it starts to give me a YAML preview and adding details to it as well. So let's define the rule for this specific merge request approval policy. When any security scan of type secret detection run against default branch and finds any vulnerability, you could define more than one or more than two. You could define the severity level that, hey, I don't want to know the results for like unknown info severity level. So you could unselect that. Any new vulnerability or previously existing, all the vulnerability states. So this is the rule where I define, hey, do a security scan of secret detection. It should run against the default branches, and I should have at least one approver. We could define the role, like if you want to have a group of people, or a specific role tied up to approving the policy, or an individual user. For our workshop, let's trouble Logan for that. So let's add, and this is for all of you, you can add the required approver to be Logan for now. All right, so we have done this. We have selected an individual user, which is Logan Stucker, as the required approver. Make sure to uncheck any prevent pushing or force pushing. So that's what we want, right? We want a couple of options if you see in the advanced. Prevent branch modification, which is fine for now, but I definitely want to uncheck prevention of pushing or force pushing for now. Prevent the approval by commit author. Of course, I don't want, if I'm writing the code, I just don't want the committer itself to approve the code. And it also have the fallback options, right? So if in case the policy criteria is not met, do you want to allow the merge request to proceed? Do you want to block until the criteria met? So currently we'll stay with fail closed. All right. Configure, keeping the options as is, but just uncheck prevent pushing and force pushing option here and configure the merge request. All right, so as soon as we merge this, so again, how we started, anytime I create the policy, I am under the base security project. Once I create the policy, I get redirected automatically to security policy project. So this is an advantage where you don't have to go back and forth. It simply redirects you and asks you to merge the code within the security policy project here, right? All right, so next up is this is merged. So this is what we did so far, right? We had a base security workshop. We tested our pipeline scan execution policy. We made some changes to the code, changed the title in the last lab, and looked how the scan results came up. Now, what we did right now is we added like a approver, which is Logan for now, who can approve or deny any merge request, looking at the vulnerability found out in the code, right? So next we want to do is a scan execution policy. So remember when I said we could define triggers or schedules to basically do security scannings. Let's do that. So within Secure tab, under policy, look at the project here. It is base security workshop. Under secure policies, I want to create a new policy. We will test them all in one go towards the end, but just let's define the policies first. So scan execution policy is what we are going to do. And again, like I said, this would enforce a few scanners, could be secret detection, which we are going to do for this lab, but could be dependency scanning, SAS, DAST, etc., to run against a specific trigger or a specific schedule. So let's create secret detection scheduled policy. Let's define the policy execution. Run a secret detection, or like I said, you could select another scanner. But for this lab, let's select run a secret detection. Keeping all of this as is, you could do not do it for this lab, but you could even select like specific tags, define a specific security job template, or you could use like, for now we'll use the default one, but you could even have the latest one, any customized CI variables, and define a condition there, which is, like I said, any trigger or a schedule. Right now we'll go with the schedule action for branches, for default branch with no exceptions daily at the midnight on during my time zone, which is Eastern. So what I've done, I'm trying to define a scheduled secret detection policy. I'm currently applying to this project and putting a condition that this should run as a specific schedule over default branches daily around midnight in the Eastern Standard Time Zone. Going back to my instructions, so this is what we did. And we just want to configure the merge request and click merge. So configuring the merge request. See, it would change here. We got redirected to the base security workshop security policy project and just merge it here for now. All right. One final step, as I talked about, there could be certain vulnerabilities and those are maybe like some info level, or they are currently being worked upon by my team, right? So due to the high amount of vulnerability existing on a project, we want to set up a new vulnerability management policy to mass resolve certain vulnerabilities when no longer detected, right? So we would want to, in one go, we would want to resolve a certain vulnerabilities which are no longer detected. So this is the final type of policies called as the vulnerability management policy. So while we are, again, just be mindful that after you created the scan execution, you would be redirected to the security policy project. So through the breadcrumb, go back to the group, again back into your base security workshop. And then under secure policies tab is where you want to define the new policy. Okay. So we did the merge request where we added login. We did a scan execution policy where we defined a schedule to run secret detection midnight in Eastern Standard Time Zone. Then we also did a pipeline execution policy where in the very beginning of our labs, we enforced a set of templates as the pipeline to be enforced across the project that I'm currently using. And then finally, the vulnerability management policy. Let's select that. Vulnerability management policy. Just that. And do we want to do it for all scanners to just okay, so here we want to do it for a dependency scanning. So let's change for now for clear all and just select the dependency scanning. All severity levels should be changed to critical and high. So uncheck this and select critical and high. And then we would want to mark, like just configure the merge request and merge. And again, we are in the security policy project now, redirected there. So merge the request. All right. So next up, we defined like in this lab, we defined three policies. Merge request approval, scan execution policy, and then the vulnerability management policy. Let's test that in action with secret detection. So all we have to do is going back to my group level so I can get inside the security workshop. Again, trying to do some code editing. So edit the code, like once you're there in the repository, edit the code and go to the web IDE. So I could see my files here, expanding CF sample scripts. So this is the folder you want to be, and inside that eks.yaml. What we are trying to do is, I'm trying to intentionally put some sensitive data here, such as AWS secret key, and trying to test how does it react and how does it blocks the merge request to be approved and how these policy gets kicked in. So let's just copy. If you go back to the instruction, it'll say the same. You have, this is the location where you want to make changes to the file. Currently, look how, closely it can watch and find out what's there. Change the description, which is currently the name of the IAM role is EKS to assume, to this one. If you look at this description, we have the AWS key ID added to this description. I'll just copy this and change the description at line number 6. Look how I'm introducing an AWS key ID within the code, just within the description. I'm going to create a new branch and commit the code. Okay, this time I won't repeat the mistake. Secret data detection. So adding the commit message, creating a new branch and committing that. Just press enter to keep the name of the branch as is. So I do that and create a merge request, secret data detection. One thing that I want to do is I want to change this to merge, like merge request can start. I don't want it to start now, but I want it to start at a specific schedule. Let's put like 2 days from today. And I think, do we want to uncheck? After this, yeah. So make sure that you uncheck delete source branch when the merge request is accepted. So let's uncheck that. Make sure that you define the merge can start after like 2 days or any time that you would want to put in. And that's pretty much it. So create a merge request. All right. Again, we are back to the point where it would take a couple of minutes, a couple of seconds to a minute. And we would come back with Yu Chen, my fellow SA, who's going to take over from the next lab. Yeah, so that's pretty much it. We'll come back and review the results of this in the following labs. All right, team. So I hope this was interesting, and uh, we'll wait for this. Logan, do you want to take like a 5 minutes break, or shall we proceed?
Yeah, let's go with another 5 minute break. I'll still be around, so for anyone that's still working through the content, if you have any questions, feel free to throw that in the QA channel. Otherwise, we'll meet at the 37-minute mark.
All right. See you, team.
Hey there all, I'm Yu-Chen. I'll be taking you through the Lab 3 and Lab 4 segment of the workshop today. Hope everyone's back from break. I'm going to go ahead and do the hardest part, which is share my screen. Just give me one moment, please. See there, just finding the right desktop. Give me one moment. All right, let me ask Logan for a AV check. Are you seeing lab number 3, Logan?
Yep. Software bill of materials.
Great, cool. I had several desktops going, so I'm glad I got the right one. Okay, so for our audience today, my name is Yu Chen. I'm one of our security specialists here. Thank you, Anita, for taking us through part 1 and part 2. As a quick summary of what we've covered, Nikita's walked you all through setting up several types of security policies that GitLab supports. Those being scan execution policy, pipeline execution policy, vulnerability management policy, and a merge request approval policy. And those are centralized in that project that is called a security policy project. And it's stored as versionable policy as code. Okay? And that's where we're going to pick up from. I will disclaim I am on a very small traveling laptop. So I will be going back and forth between the two tabs up here. I don't have a nice monitor setup like Nikita does. Okay, so please bear with me as I go back and forth. We'll go ahead and start with, sorry, let me get my slide share going. I apologize. Was not on the right slide. There we go. Hopefully that's showing the correct view. Logan will keep you honest if it's not. We're going to pick up where Nikita left off and talk about open source license compliance and SBOM, shorthand for software bill of materials, which became a really big thing in 2021, although it was already a big thing before. And we're kind of leaning in towards the home stretch here in the 3rd out of 4 laps. All right, so the problem statement here of why open source license compliance is important is probably not lost on any of us in this session. It has to do with a number of unfortunate breaches that have been happening for quite some time, but really spiked up in the last half decade. Some of the most famous ones, or most infamous ones, is probably the right way to talk about it, would be the ransomware incident in Las Vegas, where several casinos had to pay out a ransom. And I believe the total damage from that was about $100 million, and that was in 2023. SolarWinds probably needs no introduction, right? That was a really big breach that had to do with CI pipeline security. And Log4j, of course, kind of shook the entire Java world for quite some time. And that actually came on the heels of, some of y'all may remember, the Java deserialization vulnerability from about the 2017 timeframe, which was similarly impactful as far as blast radius. That ultimately led the federal government to actually issue a mandate that any of its software providers must provide a SBOM starting in 2021 for any deliverables that it provides to our government. So as part of the next exercise here, what we are going to do is we're going to actually show the GitLab SBOM. Nikita gave you a sneak peek earlier. I also want to call out, because this is not always apparent, that we do have the ability to ingest SBOMs as well. The use case for that would be some folks may not have access to the SDLC for a particular product, but they do have the bill of materials. And that's something that GitLab can pull in and analyze, okay? The formats that GitLab supports for ingestion is CycloneDX. It also produces CycloneDX that is kind of a de facto industry standard. There's another one out there called SPDX. We are developing support for that soon. The big difference, there's a lot of differences, but the big ones would be that CycloneDX is generally preferred by dev teams. SPDX, however, tends to be preferred by legal teams because it has a good deal of copyright information within it. The GitLab SBOM, we'll see it in person in just a moment. It is rendered in the product UI. And of course, it can be exported in a couple of different formats, chiefly CycloneDX, like we said. All right, let's go ahead and jump right into lab number 3, software bill of materials and license compliance. Go ahead and pull it up. As we all know by now, step number 1. Oh, and just to show you where I am, you all are probably here already, but I'm in the base security workshop project. And go to issues and click on number 3. And I like it filling up my entire browser window, so I'll look at it this way. All right, step 1, go ahead and assign yourself this issue. And we'll go ahead and start with step 1. And I'll go ahead and highlight what I'm going to cover, so I don't have to necessarily keep coming back as many times as I would otherwise. All right, we're going to go through steps 1 through 4 and see what an SBOM looks like. All right, so it's pretty simple. Because Nikita was kind enough to get everybody set up with a dependency scanning job, you will sometimes hear me refer to that as SCA, software composition analysis. I use them interchangeably. We can go to secure dependency list. And what we're going to see here is the SBOM in the product UI. I've completed the same set of lab steps that you all have. And along with a listing of what open source components are within this project, I also get a list of associated vulnerabilities, right? Which is nice and referenceable. And they do show the same triage panel that Nikita had showed you earlier. This one actually, interestingly, is not expected to be exploited in the next 30 days. And it has no known exploits. So as Nikita pointed out earlier, that may be something to augment the CVSS 3.1 base score with when determining real world threat. Well, this is great for folks who access the GitLab UI. However, if you focus on the export button here, there is the ability to export as JSON, CSV, if you need to hand this off to, for example, an auditor, or of course, Cyclone DX. All right, any of these are viable options depending on what your particular needs are. One of the questions that comes up, excuse me, quite frequently is, hey, we just use Log4j as an example. So how is it that I can find Log4j where it lives throughout my portfolio? I believe that was one of our exercises down here, right? If you want to see the instructions, there's a blog post that's been linked to. I'll show you kind of, let's call it the quick and easy way. All right, so you can actually search for them right up here. Now, what's going to be more interesting, of course, is if I go back to my group, and this is not in the instructions, I'm sort of taking a little bit of creative liberty. Typically, it wouldn't be just one project within my group, right? This is going to be a portfolio, probably representing a line of business or a business unit, or at least a team. It's going to have multiple projects. So what I could do there is do secure dependency list and get the group level SBOM, which encompasses results from all of those projects. And then I can say, what component am I looking for, right? In this case, they are indexed. So I'll say I'm looking for log something. In this case, I don't have log4j in this particular project, but what's been indexed is a component called logsave or actually login. So let's go ahead and have a look at that. I'm not too concerned about the version right now. And immediately I can see, yeah, it's got a high severity defect and it exists in a particular project. And I can click to that project. Guess what? It's the only one that we have within this group, right? So if you had more projects, this would definitely be nice for finding the needle in a haystack of where's log4j throughout my entire software stack, through all of my assets. All right. Let's go ahead and move on to license compliance. This is something that, quick side story, I guess. I started working on license compliance in the year 2004, right? It was an open source framework called Qt. In the States, we tend to call it Qt. In Europe, it's, I'm sorry, I got that backwards. In Europe, it's called Qt. In the States, we tend to call it Qt. And it was an LGPL 2.0 licensed framework. So at the time, there wasn't a whole lot of understanding about the considerations of consuming open source. But fast forward about 20 years, and there's now a fairly sophisticated understanding of what the needs around safe consumption of open source are. So with that in mind, let's go ahead and go through steps 1 to 3 first. All right, we're going to go ahead and first of all, have a look at how we understand the types of licenses that are being utilized via the SBOM. And then we will go and create a new license policy that says, hey, there's some infectious licenses out there that we would not like to use, right? The LGPL family is pretty common, especially LGPL 3.0, because that has DRM protections in addition to being very, very infectious. Okay, so let's have a look at how we're going to create a policy to say we don't want to accidentally ingest LGPL 3.0 because one of the lessons learned over the last 20 years of consuming a whole lot of open source by all enterprises really is that a technical vulnerability is absolutely dangerous. However, it is unlikely to end a company as a going concern. A license policy violation, however, can actually be far more devastating. All right, so let's go ahead and go back to our SBOM first and have a look at what types of licenses are within it. Go to secure dependency list. And I'm gonna, we picked on the top of the list last time. Let's go ahead and pick on the back of it. Or you know what, let's pick lucky number 19 and go to the middle, right? If we look at component, I'm sorry. Oh, sorry, there's a chat message. Oh, okay, sorry, that's just Eric giving us a thumbs up. My bad. I lost myself a little bit. Here we go. Excuse me. Okay, I got it. All right. So the licenses essentially are going to be called out just right here, right? I'm going to save us a little bit of time. Right, so I can see that this one actually has 2 licenses. It's big decimal. And the reason I want to bring up this scenario is I don't want to present everything within the SBOM as being an absolute, right? The sources for this information, the license that is, can come from a couple different sources. They can be something that's declared on the project website. It can come from a header file. Or there could be a license file, for example, in the README, right? And occasionally those licenses will conflict, and GitLab will pick this up. So I wanted to bring up this example real quick to say that it is important to have security professionals review the information. It's not kind of, the tool is going to do everything, right? There will have to be some human decisions. Another example would have been earlier when we showed that Logan Stucker had to approve or provide an exemption to a defect found in a merge request, right? So all of these are things that are meant to augment human risk decisions. Some of these other findings are a little bit cleaner, right? MIT licenses are generally pretty permissive. BSD, generally also permissive, right? So that's all I'm going to say about the licenses. What I typically see is legal teams will build a license matrix that says there's a certain type of application, for example, web apps or embedded apps, and those have to abide by different types of license policies because they have different ways of including and linking in the components and therefore trigger different legal obligations in their license terms. All right, what we will do, however, is take LGPL licenses as our not awesome example and make a policy that says we do not want to permit LGPL licenses. All right, so to do that, we'll be finally moving on to step 2. Okay, we're going to go to our secure policies and click on new policy. And we're going to make something called a merge request approval policy, which you all probably have seen before. All right, so we'll go through the easy parts first. Secure policies. The names I used are a little bit different than what Nikita had. All right, but let me get some Zoom stuff out of my way. And we'll click on new policy, merge request approval policy. All right. So, oh, sorry, let me give it a name. MR approval policy for licenses. All right. Now, remember how when you made policies earlier, you all used the WYSIWYG, the what you see is what you get editor in the UI. We're going to do something a little bit different this time. So I'd like everybody to go to step 4 and go ahead and click this little clipboard button here, and let's copy this YAML code to the clipboard. All right. What we want to do here is we want to author the YAML without using the WYSIWYG editor, but we're going to hand code it. So if you look at the top of my screen here, I'm in rule mode right now, but I can easily click on YAML mode, right? And in YAML mode, all I want to do is go ahead and highlight everything that's in there already, and we'll simply paste what's in the lab and replace the entire set of YAML. So this is how you can hand code policy as code if you like. Not everyone prefers to do it this way. So really you have both options at your disposal. Go ahead and please configure with a merge request. All right, should be looking at our good old merge request, or as we call it, MR for short, screen. While that's getting ready, let's go ahead and look at the remainder of the steps that we will be doing, right? Step 5 is going to be merge the merge request. Easy peasy. Next, after we merge it, remember we have a couple projects here. We want to go back into our primary project, the base security workshop project. Because what we have done in the YAML is we said we're going to do a license analysis, and we're going to focus on LGPL 3.0 licenses that are newly detected and have been detected in the past. And when one of those appears, it's going to require approval, right? In a sense, we have placed LGPL 3.0 on a deny list. All right, so step 7 would be, we won't actually do this live necessarily, at least not at this juncture, right? So simply be aware that if we were to run a new pipeline on the base security workshop project, any introduction of an LGPL 3.0 license will be flagged. All right, let's go ahead and do that. So back to the merge request where we had added the YAML to add the license policy. Let's go ahead and click merge once the button shows up for you. As it says, drum roll please, we're merging. All right, and that'll be back in just a moment. Once your merge request has been successfully merged, you are done with this particular lab because we have introduced a license policy. All right. See if my internet's just being a little bit unhappy with me. We just had some big thunderstorms clear out of the area, so hopefully everything's going to cooperate here. And when you do get to the same place I am with the merge request merged, please go ahead and do close out this issue. And once you do that, if you go back to the list of issues, you can go ahead and queue up lap number 4. Final lap. We're in the home stretch, pun intended. All right. We all know what to do by this point, right? With issue number 4, let's go ahead and hit assign yourself to get started. Check on the status of my merge request. Looks like it's still going. I'm guessing that's my internet being a little bit not awesome. So I'll go ahead and move on with the slides here. And go back into presentation mode. All right, so now that we've got all of our policies in place, right, in everything from the technical vulnerabilities that are being detected to overly permissive open source licensing, I want to talk about some of the additional features. Let's call these kind of uh, beyond basic scanning, right? I would argue that static analysis, container scanning, software composition analysis, all of those are pretty much very foundational. And whereas some other types of analysis within GitLab are not quite as heavily leveraged, and they probably should, right? So in the final lap, we're going to talk about what those additional tools at your disposal are. And the reason these tools are important is, again, I wish I could say there was a positive reason for it, but really it has to do with a severe rise in attacks on the software supply chain. The spike probably started around 2015, 2016, which kind of coincided with the rise of DevOps, cloud use, right? And that's really great stuff that accelerates software development, but it's all types of software. It's malware as well. And unfortunately, the rate of malware has increased, the amount of defects has increased, but the rate at which they're being resolved, wish I could say that's increased. It hasn't. A little bit more on something that Nikita touched upon earlier, right? And I do want to stress that this is extremely important. When I got started in the security biz, well, decades ago at this point, pretty much folks looked at the CVSS score and assessed priority of fixing that way. The world's changed a lot, right? And I just want to stress that augmenting that base score is very important. For example, by leveraging the EPSS to see if there's a likelihood that the exploit really happens, because the exploit is when the rubber really meets the road, right? It's not theory anymore. It's happened. Same thing with the KEV, or known exploited vulnerabilities catalog. If something has never been exploited, I can't speak for everybody. I'm probably going to look at that, all else being equal, as slightly lower priority than something that has been exploited, right? So just bear in mind, you have various ways to really assess real world risk, and this is a very critical one. We will also cover a little bit about DAST, Dynamic Application Security Testing, in this next module. We'll be taking it somewhat basic. GitLab supports a couple approaches to DAST. We'll be configuring what's called an on-demand DAST scan, right? This is configured through the UI. It's typically used in kind of point and fire fashion. And it's typically going to be used to test production endpoints that are already have already been deployed. There is another type of DAST that GitLab supports. It's pipeline integrated, meaning it will run on every single code change. So you have kind of dual mode operation, and we'll be looking at how one could set up a on-demand DAST scan. Of course, I would be remiss if I didn't call out how GitLab DAST actually works. The engine is actually a browser engine that will load the application, a web app, to mimic actual runtime behavior, right? The browser is actually Chromium at its core, so very popular browser. And the reason we did that is it's going to behave just like a standard application living in its native habitat. And it does handle SPAs, single page applications that require authentication, and various authentication schemes are in fact supported. It is not proxy-based. That's important to call out as well, because proxy-based will get you so far, but a browser is where the app is really behaving the way it does when the user is interacting with it. Education is also embedded into the product. We have a couple training partners, Contra Secure Flag, Secure Code Warrior. I'll show you where to access their training offerings. I find integrated training within the platform I'm using daily to be very, very nice. I will call out that Secure Flag, I believe, has a open source subscription. Contra and Secure Code Warrior are paid subscriptions. So do bear that in mind when you are considering these options. Excuse me. Finally, we will talk a little bit about audit management, right? If you're kind of getting a sense that some of the things we're going to cover here have to do with runtime considerations, you're absolutely correct. A lot of this has to do with, hey, we've done our job at design time or dev time. Now our application has been actually deployed. Customers are live customers, paying customers are using it. How do we maintain our newly achieved security and compliance posture, right? So what audit management is really, you can think of it as events that happen. So someone configured access to a repo, someone issued an access token, right? All of these will show up as a recorded event. And we'll have a look at some examples of these audit events, right? You've actually generated a few through the course of this lab. All right, that having been said, let's go ahead and get started with lab number 4. All righty. Let's make sure that there my merge request has finished. All right. And I'm going to use our breadcrumbs to go back to my group. And then we will go right into the base security workshop project that houses our application code. All righty. Let's go to the exercises. Step 1 is we're going to configure an on-demand scan. I'm going to flip back and forth between the 2 tabs somewhat frequently for this exercise because I'm going to be copying and pasting a lot, and I recommend you all do the same. Just makes it a little bit easier. Let's start with steps 1 through 4. So probably looks somewhat familiar, right? We're going to go to Secure On-Demand Scans and click the New Scan button. It feels a lot like creating new policies, right? We're going to give the new on-demand scan a name, right? I'm going to stop right there because I'll show you what the interface looks like once we get to that point. Well, let's all go ahead and do that. Secure on-demand scans, new scan. All righty. Just call this scan for work shop. What is today? 12, I believe. You can give it a description if you like. I'll go ahead and keep it nice and simple. All right, so what we have here, if you scroll down, is there are 2 components to a DAS scan. One is the scanner profile, right? And the other is the site profile. And that's why I wanted to have a quick pause here, because in step 3, we will go ahead and create a scanner profile. That's easy peasy, okay? You just hit new scanner profile, give it a name, and save it. So we'll do that together. Select scanner profile, new scanner profile. And I'll just call mine scanner profile workshop 612. We'll leave all else the same, but I will call out in passing that we're configuring this for passive mode. If you wanted to actually attack the target, you could set it to active mode. Standard disclaimer, please don't do this to a real production app, right? And there are other configuration options, like how long to crawl. There is a spider involved, and also how long to time out, okay? But we're going to keep everything default for today and save off that profile. So what's the next step? We're on step 4 now. The site profile. Site profile really is what is the target that we want to hit? What's the URL? Okay. So first things first, we're going to use the good old example.com website, and that's going to be our target URL. So what we do here is we're going to go to site profile. All righty. We're going to hit the select site profile button, new site profile. I'll just call this site profile workshop 612. It is a website. Okay, we do support API security scanning as well, but in this case, it's a website. Target URL, we're just going to put example.com. Excluded URLs, as the exercise says, we're going to put the logout URL. Okay, in case the scan runs for a little bit, we don't want it to log out. So we are excluding the logout URL from the analysis. All right, I'm going to place my mouse cursor in the additional request headers optional section, because what we want to do here is we're going to provide some headers. Okay, so additional request headers. There we go. And we have provided a sample header here in step 5 that I will copy to the clipboard. Right there. The reason we are providing this header is really for validation, right? This will tell it that this request is coming from DAST and not from an actual attack. So let's also go to step 6 in the lab and say, and let's pretend that this website requires authentication and pass it some credentials, right? Sorry. Yeah, there we go. So the way we've written this, you're going to fill out into the UI. Okay. So I'll copy example.com login onto my clipboard. And that's the authentication URL. Username is simply user. Password, I'm going to put in pass. Looks good enough, right? Let's go ahead and give it a try. I suspect there might be a problem here, but we'll give it a go. Okay. I get an error. Cannot create the site profile. Password is less than 8 characters, right? So there is some enforcement of good password practice here. So you know what? Give it any password you like. Just make sure it's over 9 characters. It's pretty basic, right? We do want to respect the fact that some websites may have fairly loose authentication. In my case, I'll tell you what I put in. I just put password 123, okay? And I should be able to save my profile now. There we go. I've now defined a scanner profile, meaning what kind of DAS do I want to run? Site profile means what's the endpoint I'm going to analyze? And we are now through step 6. Okay, I'll highlight the steps I'm going to talk about here. Bada bam. All right, we're not actually going to deploy this. Sort of don't love having a whole class run tasks at the same time on example.com, right? However, if you wanted to save this off as something that you can then run and you're happy with all of the configuration, sorry, the Zoom stuff is getting in my way. Just give me one moment. I'm gonna move some dialogues out. Okay, you can then save and run scan. In my case, I'm going to save a little bit of time and just say save to scan. There are other options like running it on a schedule, right? That's really up to you. We just want to go through the steps and the ingredients of how to configure a on-demand DAS scan. Anytime I want to run it, just hit that button and I'm off and running. All right. Let's talk a little bit about step 2, project audit events. This one's really, really simple. You simply go, while you're in the base security workshop project, go to secure audit events in the left-hand panel. Let's have a look at what we got there. Secure and down to audit events. Yeah. You probably see some activity that is somewhat familiar, right? They got my IP log here, timestamped. And yeah, this person named Yuchen added a DAS profile. We look further down. Here's where we set up the license policy, right? And so on and so forth. You'll see a number of activities that came from earlier in the lab, right? A merge request was merged, right? The reason that's important is, of course, the merge request is pre-merge code. It's not yet part of your code base. Once it's merged, it is part of the repository, and it's now actually part of the code base, right? So that's an important event. So you kind of get the idea. The docs have a comprehensive list of all exposed audit events, but as you probably get a good sense of what a sampling might be from the short list, not only in my example on screen, but in your example in your lab session. All right. So we've done configuration according to really what I consider best practice through the duration of this lab. What I want to point out briefly is there are a number of other ways you could have enabled, for example, static analysis or some of the other security features, right? And the reason we do that is we do recognize that we have a diversified audience, and some folks love to write code, some folks like to interface with the UI, and we want to support any of those working styles. So as an example, if I were to go back to my base security workshop project and go over to secure, we haven't visited the secure configuration area before. Let's go ahead and give it a quick look, right? SAST could have been configured. We did it through a policy, which I think is best practice because policies are reusable and can apply to multiple projects. However, it was an option to say, let's go ahead and configure SAST right within this project, right? I'm not going to do it at this point since we already have a policy in place, but this would actually walk through a wizard how I can enable SAST on my base security workshop project. Okay. The other thing I want to point out is we talked about, sorry, let me just move some stuff out of my way. There we go. We talked about those training providers. There is a vulnerability management tab here where you have the option to turn them on or turn them off for that matter. Okay, so this is where you access your in-product training. So there is a lot more to the extra scanner configuration. For example, there are lots of other types of scanners that can be configured, but do note that you have multiple ways to enable them. In fact, one of them I didn't even cover live. There can even be variables added to our project level pipeline, right? So there's a couple different entry points depending how you like to interface with GitLab. All right, let's move on to step 4, code owners. This is one of my favorite exercises because this really shows you, once again, how the security gates, especially pre-merge, work within GitLab. A lot of you may be familiar with the code owners notion within GitLab, but then it's exactly as the name implies. It denotes who owns code and therefore whose approvals are needed in order to get a code change successfully merged, or in some cases, perhaps refactored before it introduces defects that could have otherwise been prevented. So let's go ahead and create our first or update our code owners file. Okay, we're going to go through step 1 first. I'll be pretty deliberate in this part. So we're going to go back to our base security workshop project and open the web IDE. And we're going to make the code owners file. Okay. And I will also do step 2 at the same time. Just because that's easy, I'm going to put the code in step 2 onto my clipboard. All right. I'm back in my base security workshop project. Remember how earlier Nikita showed you in the merge request to go to code to open the web IDE? We are not in a merge request, so we're going to go to edit and click web IDE to get to the same interface. If you use VS Code, it probably looks real familiar to you, right? It's kind of a web-based version of VS Code. You can think of it that way. And I'm going to go ahead and just right mouse click in the root of the repo, click new file, code owners, paste in the content. One thing that I would like everybody to do is sorry, if you notice this big bold print, right? Replace the GitLab username with your username. what we're referencing is line 2 of code owners. Put your GitLab alias, please. In my case, I put my alias is YHSUEH, and I'm going to change line 2 to say YHSUEH myself owns any file with the extension gemspec. Now on line 5 you can leave alone. Please do not change line 5. Line 5 says Logan Stucker, my colleague, owns the README. Okay? So that is step 2. Step 3, you all are probably familiar with at this point. We're going to commit the change. All right? So I'm going to do this just a little bit differently. All right? So what we're going to do here is go to the source control button on the left-hand side. You all are familiar with that. It's a little arrow icon. Add a commit message. Okay, and put commit and push. However, we are going to use the resulting dropdown to commit to main. All right. So let's go ahead and do that. Right here, this is our pending change. And I'll say added code owners. And just to make sure I'm following along correctly, commit and push, right? Commit and push to main. And yep, go ahead and push to main. And we can actually go to the project. I'll go ahead and close out some of these tabs here since we are back in our base security workshop project. Okay, you now have a change which has added a code owners file to the repository. So what is this code owners file actually doing? Let's have a look. This is actually, I'm just going to scroll down and show you. It's a fairly long exercise, but this is our last one. So hang in there. We're going to see code owners in action and that license policy we created in action as well. I'll highlight the parts that I'm going to go through. Let's start with lines 1 and 2. All right. So from the main page of our base security workshop project, we're going to go back into the web IDE because we're going to edit a file. All right. Remember, where's the web IDE live? When you're not in a merge request, it's under edit. The file that we want to modify is called tanukiracing.gemspec. All right. In tanukiracing.gemspec, we want to focus on line 22. All right. It calls out dependencies. And what we want to do in tanukiracing.gemspec is on line 22, excuse me, we want to add the reference line before the current line 22. So we're basically going to bump line 20, the current line 22 down to line 23. Going to add a new dependency. Okay, let's go ahead and do steps 1 and 2 now. Going to go to edit, web IDE. Tanuki Racing at GemSpec. Here we are. Line 22. So we're going to add it before. We'll bump the current line 22 down to line 23 and add that new line of code, right? You can see actually Duo is suggesting additional dependencies. Thanks, Duo, but I'm good. Okay, so we've made our change to the gemspec file. Now let's look at step 3. Okay, we're going to replace the entire contents of the gemfile.lock bundle. All right, so let's see where that is. There it is, in the root of the repo. And we're going to replace the contents, okay? So I'm just going to Control A, get rid of everything that's already there. Paste the contents of what's listed in the code in step 3 onto my clipboard. and replace that entire dependency list. All right. There we are. Once you've modified the lock file and the gemspec file, we are on to the next few steps. I'll take 4, 5, and 6 in one shot because this is something we've done before. Right? But, oh, actually, you know what? I'm going to do something a little bit different. I'll take it slower this time because we are going to create a new branch in this case. The reason is we want to see how the scanners work on a pre-merge basis, right? So what we're going to do here on step 4 is click that source control button like we did before, add the commit message is good practice, but then click the down arrow. All right? So we're ready to submit our changes, added dependencies. Okay, and we're going to hit this down arrow here, not commit and push to main, but the down arrow. And we're going to take the option create new branch and commit. Okay, and you're going to have this little prompt up here. What you want to do here is actually just hit enter. You can set your own branch name if you want. I'll take the prescribed default. And when the pop-up comes up, that gives you an option to create MR, please go ahead and click the create MR button. All right, so I'm hitting enter on my keyboard. I'm going to get the prompt in the lower right, and we'll create that MR. And again, just to keep my screen a little bit clean, I'll get rid of some of my windows here. All right, you all did this before, but remove the mark as draft from the merge request or MR. And also go down to the bottom, merge options, and uncheck delete source branch when merge request is accepted. That was step 6. Okay. Now we're going to go ahead and hit merge. Or I'm sorry, I got ahead of myself. Create merge request as the lab reads, not as I say. Okay. All right. So it is merging. It is creating the merge request right now. Once that merge request has been created, here's what's going to happen. Step 7, our friend Mr. Logan Stucker. If we've done our job right, he should be prompted to approve a change. Why is that? Because he is an owner of one of the files that we have changed. We'll talk a little bit about the details of the merge request when we get there, but it should definitely block and say this code cannot be merged until Logan Stucker approves it. Okay? And why is it going to do that? Because not only do we have the code owner's protection in place, but the license policy is also going to kick in. We'll see that in action in just a moment. All right. And again, the reason it's vital in the merge request is it's kind of your last chance to take on the philosophy. Prevention is the best cure. After the merge request, everything is essentially part of your code base, and technical debt has, in fact, been introduced. Right. I see a number of, looks like questions coming in to see if there's anything I can provide clarity on. All right, cool. Looks like Logan's on top of it. Thank you, Logan. Right. So we'll give that just a moment. I think my system is kind of not awesome today. If you are ahead of me and your merge request has gone through already, and you are seeing the fact that Logan is being prompted to approve your merge request, you can go ahead and close out this lab just by clicking the close issue. All right, I'm going to take just one moment to do a little housekeeping here, if that's okay. All righty, get back to my desktop. Okie doke. this is the end of our prepared materials. So if it's all right, let me go through the rest of the slide deck while this merge request is processing. Sorry, there we go. That's my slide deck. All right, so we've now explored license policy, on-demand DAST scans, audit events, some extra ways to configure our security scanners, and we've looked at how the policies will kick in via both the security policies we made earlier, as well as the code owners file. Lap 5 is optional. I recommend doing it if you either didn't get a chance to go through all the steps of the workshop today, you want to take something home to play with pre-made projects and configurations. It is entirely up to you. I won't necessarily go through this live. I'm sorry, I will, because I just want to show you where the transfer project interface actually lives, if you do want to take this home with you. All right. So let me just use my spare browser window here. I'm going to go to the base security workshop project. If you go to settings, go to general, go to advanced, or expand advanced, I should say. Transfer project. Okay. Let me go ahead and the Zoom stuff keeps getting in my way. Sorry about that, y'all. And I personally have a workspace on GitLab.com called HSUEH-demo. So I could take this home with me and put the project into my own workspace to play with at my leisure if I wanted to. Please don't hesitate to do it. You can honestly still access it in the existing workspace if you wish, but you have a couple options here, right? As Logan said, that workspace expires on the 17th, whereas if you were to transfer the project, you would have it pretty much forever for as long as you want to experiment. All right, and that is really it. The conclusion is, of course, transfer when you're done, right? And I just want to wrap up real quickly. I know my merge request has taken a while, so we will put eyes back on it momentarily. Why is all of the other things we've covered important, right? So Nikita started off with some of these problem statements, and I just want to reiterate them. It's that for as long as I've been working in security, the experience between dev and security has not been awesome, right? And we want to smooth that out for both the dev teams and seamlessly allow security scanning and maintenance of security posture to be part and parcel with the dev process in the CI pipeline, in the merge request. That's hugely vital, right? Because end of the day, it's the devs that are remediating any defects found. And we also want to make it easier for security professionals to do their job. They can author policies, right? And have that separation of duties. That's vital. Using fewer tools to reduce fatigue, reduce the propensity for error, right? And really unite all the teams. Here at GitLab, we actually used a merge request with all of our teams, even quote unquote less technical teams, right? So our marketers use it, our business analysts use it. It's a meeting ground for everybody. Most important thing to my heart is for decades, I've worked with customers who use every tool on the face of the earth. The problem is a bunch of them become shelfware, a bunch of them are clunky, and people get kind of not so pleased with them, and they just don't get used. So we want to make sure via policies, via good collaboration, that people do adopt tools. And these pipelines, our policies can work with third-party tools as well. So whether you're using the scanners that ship with GitLab or ones that you have procured elsewhere, we want those to be part of the pipeline because after all, we're all consumers of each other's products. And of course, happy compliance auditors means happy going concerns as companies, right? So that's really the importance of the time we spent today as far as the broader scope of what matters to enterprises. And we will go to live Q&A momentarily, but I want to see if my merge request is going to cooperate with us. If it doesn't, I'm not going to make us necessarily wait for it. We can go to Q&A and have a gander at the results once it's up.
Just a quick comment on this. Right at those last 20 minutes or so, GitLab.com did start to experience some issues. So to account for that outage, your groups have been extended until the 22nd. So you pretty much have 10 days to mess around in these groups, test out security features. Again, everything's turned on. So if you want to mess around with Duo, that's available, write your own pipelines, etc. And then on that 22nd, the groups will start to tear down.
Thanks for saying that, Logan.
Yeah.
It wasn't my internet after all, right? We're just having a little bit of plumbing issues right now.
The other thing I wanted to show, so with live Q&A, if you have any questions that you want us to answer live, please go ahead and throw those in either the just regular Zoom chat or the Q&A chat. But we do have a security dashboard that I want to show off. As we touched on this before, security dashboards in general do take at least a day to populate. That was kind of the problem we were seeing. If I shared this, you can see what it looks like over time, right? So this is an application that we actually work on and develop. In this case, it's the same application we just used for said workshop. You can see over time, you'll get the different stats and the breakdown of what type of vulnerabilities are introduced, how are we fixing them. Of course, in this case, it's horribly insecure. That's on purpose. Otherwise, we wouldn't have anything to show you with security. But yeah, I just wanted to show that before we jump into live Q&A. Okay. Question came in, and anyone on the GitLab side can help answer this. My company mandates using checkmarks. Can the GitLab UI have visibility to checkmarks and publish into the vulnerability reports and other sections of the security screens or MR tabs?
Yeah, good question. I can take that one. Before I came to GitLab, I worked at a pretty well-known security company in pro services, so I was able to kind of have hands-on experience integrating a number of tools. The answer is yes. So it's not just for check marks, it's for a whole lot of third-party tools out there. The most common adoption pattern for visibility of third-party tools findings in GitLab is to import or ingest the results, right? The requirements for that would be if the tool, and I know checkmarks can, that's one that I've worked with, if it can produce a serif, S-A-R-I-F format report, that is something that actually, I mean, it's an old school format, came out like turn of the century, and it will format the GitLab schema very, very easily. It's a simple transformation, and those reports would then be available within the GitLab vulnerability report. If you wanted to, you could go one step further and put them into the merge request security widget and potentially gate upon the checkmarks results. And you can probably plug in a whole lot of other vendors there as well. Very long way to say yes. It's a good question, Kyle.
Sweet. And then Eddie just sent some documentation. I'll go ahead and send that as well.
Awesome. Thanks, Eddie.
I don't see any other questions at current, but we'll hang out for a few more seconds if anyone has anything.
Okay, if nobody has any other questions, I'd like to thank everybody for spending some time with us today. As mentioned throughout, a recording will be sent out to you via email. Oh, we do have another question. Okay.
The question is, are some of these features only on GitLab.com hosted instances?
Good question. I can feel that one. No, everything you've seen here is available in GitLab self-managed and GitLab.com. Of course, the differentiation being when there are new features beyond these, typically GitLab.com will get them as beta first, enabled by feature flag, whereas self-managed You could potentially enable a feature flag yourself, but generally that's really the only difference as far as timing. Everything you saw today, none of these are experimental, none are beta. There's going to be parity between GitLab.com and self-managed.
And just to build on that, almost everything was tied to an ultimate license, though. So if you are using a free version of GitLab, you probably don't have access to some of those features. That would be why the groups you're using have ultimate and enterprise turned on.
Good question. Anyone else got anything? Keep them coming. Y'all letting us off easy today? So looks like maybe we're getting
Hey,
off easy.
we're done
Please
with
do
questions.
send us other questions. So sorry, go ahead, Alexa.
No, we're happy to stay on for a couple more minutes if anybody does have questions. We've had a good couple so far. If not, once again, I just want everyone to know that a recording is going to be sent out in an email along with the slide deck as well. Also, just want to shout out, we do have another webinar coming up on July 17th. It is going to be a CI hands-on workshop. It'll be the same time, 9 a.m. Pacific time. So if anybody wants to join that, we'll have that going on as well. And if that's everything, it doesn't look like we're getting more questions, then thank you everyone for joining and hope everybody has a wonderful rest of their morning, afternoon, evening, wherever you are in the world. And this will be sent out again. So everyone, thanks so much and have a great rest of your day.